Okay, folks, okay, year 12 students. So we are told in the question the equation x squared plus kx plus 2 equals 0, where k is a constant, has no real root. Okay, so that's going to be quite important in just a second. Find the set of possible values of k. Well, if this quadratic has no real roots, it means that the discriminant, so the bit inside or underneath here, the square root of the quadratic formula, b squared minus 4ac, that has to be strictly less than 0, okay? Because obviously I can't take the square root of a negative number, okay? So I can't take the square root, let's say, of -1, okay? That's not possible, okay? Of course, if you do A-level further maths, of course, yes, we've got, yeah, complex numbers and imaginary numbers, but in this video, I'm not looking at that actually yet, okay? I'm looking, yeah, just strictly about what happens here when we don't have any distinct roots of a quadratic, okay? So, the coefficient of of x is going to be 1, so a is equal to 1, b is equal to k, so the coefficient of x is equal to k, and then c is our constant, so c equals 2. I can now substitute these three values into here, creating my quadratic inequality or expression. Okay, so what am I going to have? I'm going to have k squared minus 4 lots of a times c. Okay, so that's going to be strictly less than 0. So we're going to have a quadratic now. So we're going to have k squared, okay, minus 8 is less than 0. Now this one here is a bit harder to actually factorize, but we'll leave it here in third form. So if I factorize this, this will be k plus root 8 times by k minus root 8. So think of it as difference of two squares, except here I've got obviously a third rather than a square number, but the same rules still apply. I can still factorize this, okay, into this form. Okay, that's going to be less than 0. So less than 0. So my solutions will be minus root 8 and positive root 8 on the x-axis. And we want to know, okay, where this quadratic inequality is below the x-axis. Well, it's below it in this region here. Okay, remember, yeah, when it's obviously less than 0, it means, yeah, the point or the points at which, yeah, the quadratic graph or the curve or whatever I'm looking at is below the x-axis, not the y-axis. Okay, so it's below it between these two regions. So our answer will be minus root 8 is strictly less than k, which is less than which is less than positive root 8 or root 8. Of course, I can actually simplify that if I want to. Root 8 is root 4 times root 2. So I can also write it as minus 2 root 2 is less than k, which is strictly less than 2 root 2. Okay, that also works. Let's just delete that and write that again. Okay, and that, guys, is our final answer. Okay, so when we have no distinct real roots or no distinct roots, it means that the discriminant, so the bit, the part of the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So it's the bit inside the square root, okay, that has to be explicitly less than um, so less than 0 for us to have no real distinct roots of a quadratic. Okay, so this is what I call the discriminant. Okay, so you would have obviously seen it when you first started learning about this in September, October of last calendar year, okay, or this academic year, if you're in year 12. So discriminant, okay, sorry if I spelled it wrong. Discriminant, I think that's right. Okay, so yeah, okay. Now again, we're not going to obviously think about, yeah, obviously complex numbers, yeah, or imaginary numbers. We're just looking here at the set of values, okay, of k, such that this quadratic has no roots, i.e. it does not cross or intercept the x-axis, okay. So if k takes the value between, okay, minus root 8 to root 8, so not including both, okay, so in between those two values, then this quadratic has no real distinct solutions or no real roots. Thank you.